Welcome everybody. Last cycle we had what we called a crazy Halo cycle. Crazy because instead of like working and fixing on one app and like trying to make it the best state we can, we decided that we will rather set with so quality, good enough to run, but we will instead focus on 3 apps instead of just one. And these apps were Loki, Promptail. Promptail is part of Loki package, Linkerd, and Flux. Let's see. So what I wanted to show you today is composed of like 2 parts. First one is demos. So I will show you briefly how these apps work and how we are using them and what you can use them for and what our customers can use them for. And then because there's already quite a lot of interest around Loki, I will focus for a few minutes more on Loki and tell you about what we got there, a bit how it works, and also quite a bit about how we can already use it. First, a disclaimer. Because we did like all these apps in a single cycle, they are in a good enough state for testing and testing only. They're not really ready to be used in production. But we deployed them for ourselves on one cluster. I will demo this in a minute. But yeah, again, good for testing, including probably testing with customers, not good enough to run in production. So first up in the set is Flux. Flux is a GitOps tool. So basically it means that you write all your configurations in some source code, you store that in Git, and then this configuration is applied to your clusters. In the simplest scenario, Flux takes your YAML manifest of objects you want to have in Kubernetes and applies them to a Kubernetes API server. And that's it. And then it keeps them in sync. It can target different clusters, I mean remote clusters from the one it is running on as well, but that's for us currently out of scope. So right now, we want to use Flux to keep our CRs in GitHub, be able to do pull requests, be able to see diffs, be able to roll back to a different configuration that we had before with just single command, and still have all of that applied automatically on the target cluster. So it's really nice. Our idea was to use that to keep up CRs and associated config maps and secrets, and then have them automatically synced and applied on the target cluster. But there's one problem. The problem is, what if I want to keep secrets in the repository? Obviously, secrets are not encrypted when you store them as a manifest. This is just base 64 encoding. So the only thing that is actually guarding us from exposing live our secrets is that the GitHub repo is private and not public, which is slim protection. So there is a tool that is called SOPs that can rescue us in this situation. One of the ways SOPs can work is that we create a GPG key, and cluster has this GPG key, and we have public part of it. And we can encrypt the secrets that we want to keep in the GitHub repository with the public key. And then Flux automatically, when it sees that a secret comes in and this secret is encrypted, decrypts, because the private key is included in cluster's configuration, on the fly decrypts the secret and stores on the server as a normal, plain old secret. But the important property here is that you never keep unencrypted secrets in your repository, so you're not risking exposing your secrets. Our Flux is currently targeting control plane or management clusters, because that's where we keep our app CRs and associated configuration CRs, and we want to target different clusters from there. So it is running right now on Gorilla and on Golem in the Flux app namespace, but we are actually using it mostly on Gorilla. We have created per cluster GPG keys for SOPs, and our experience so far is that we just love it. Just to give you an example, when we were experimenting with Loki and something was wrong on AWS, it was actually easier to delete the whole cluster and all the apps configured and installed there than to try to fix AWS site, because everything was recreated by Flux. And that's the short intro about Flux. Now, also demo. As a demo, I will show you just the repository. So how the configuration looks like when you want to apply it for a cluster. So over here, this is a Gorilla repo. So Flux that is syncing GitHub from GitHub to control plane Gorilla. And manifests, yeah, there's something that is not really great. You have to remember to put every single file you create for usage with Flux in this customization file. It's easy to forget about it. That's the whole downside. But then we have a cluster Loki 0. It is the only cluster managed so far by Flux on Gorilla. And over here, let's see, for example, Linkerd 2 app. And we have over here just two files, appcr, which is our plain old appcr that has just one single config map referenced. And this config map is also over here in app values file. And it is also our plain configuration config map associated with appcr. That's it. After you put both of these files into the master branch of this repository, Flux will take care of the rest. So it will take those objects, apply them on the control plane in the correct namespace, and so on. And from there, app operator picks them up, targets the Loki 0 cluster where this is all happening, and we get apps installed on the target cluster. Okay, answering your question, Fer, so far we have created one key per installation. So it's the same key for all the deployments in installation so far. It is possible to use different keys for different customizations, I think, but it's on this level. But so far we're using a single one.
Yeah, you can specify multiple keys, and then Flux tries every key until one matches, so you can use multiple keys in a single customization.
Yeah, but you can also use disjoint keys, right? I mean, different keys, not overlapping ones between customizations.
Yeah, that's what I meant. So you can generate like 15 different ones and then put it in the secret for Flux, and then Flux will try everything out.
Okay, so one more example, a little bit more complex scenario where we have an application. This is Promptail app. Again, nothing really surprising here, but we are using both config map and the secret because we need to store a password over here. This is the password that Promptail uses to connect to Loki instance. More about this will come. So app values, just to show you, it's pretty long, but we are targeting the secret over here. I need to store this password in the repository, and I don't want to make it plain text. So here's the secret part that includes SOPs encryption. It is like a normal secret. So for example, the metadata section is pretty normal, but there's a special SOPs section that is parsed and used by Flux when this secret is synced to the repository. Over here, there's a PGP encrypted AES key, so symmetrical encryption key. And this encryption key was used to encrypt the value of this data field. So SOPs on the fly gets the PGP message, unencrypts the symmetric key for AES, unencrypts this value, puts unencrypted value over here, and then saves this as a normal secret on the control plane. So we can deliver this safely. And that's it. That's it about Flux, about how we use it so far. So far, our experience is really great. Next one on the list is Linkerd, a project I mentioned already a couple of times. It's a service mesh solution that is like focused on being easy to use, so it requires very little configuration. In the basic scenario, as a customer, as a user, you don't have to configure anything. You deploy it and you already get some of its features without any configuration. So basically, in this scenario, no CRs are needed. CRs are required only to configure some of the functions, not the basic ones. You get MTLS, so mutual TLS end-to-end encryption between all the pods using HTTP, gRPC, TCP for free. You don't have to configure anything to get that. It's very fast, and by very fast, I mean the proxies that it is using are really, really fast, but it has less features than, for example, Istio. It is also easier to use, so yeah, it's a trade-off. One important thing, if you deploy Linkerd whenever you want, by default, it does nothing. So in the default configuration, it's all opt-in, and you have to opt in on deployment or namespace level. It is also possible to do this on a single pod level, but it's not that really useful. So we have a Linkerd deployment. It's deployed on our cluster, Loki 0. Loki 0 is our dedicated cluster for running Loki. We'll get back to it. Yeah, over there we deployed Loki for on the Loki cluster, we deployed Linkerd for two main reasons. First one is that we are not really yet very profitable with running Loki, and this gives us additional visibility of Loki. Because Loki is microservice oriented, we can easily check what's in there, what is running, what's the status, and so on. And also we get those nifty MTLS encryption end-to-end. So actually, all the services that are processing our logs have full encryption in-transit data for free. Currently, it is enabled for Linkerd, Loki, Promptly, and Grafana namespaces, so not all of them. And the deployment that we created there has zero configuration from our side as a user. So there is nothing like reconfigured for the mesh to run. So how is it useful exactly? This is our current Loki 0 cluster and the Linkerd we have there. As you can see, we have the Loki namespace over here across the other namespaces, and the Loki namespace is the only namespace that has success rate below 100%. This looks fine. I mean, response times are pretty low, 17 milliseconds. That's great. But we can already see that probably something's not right about Loki installation. And that was our main reason to run Linkerd over here. So this is all encrypted thanks to automatic MTLS, but also we get better visibility in the shape our Loki is in. And as you can see, we have a component that is called ingester, and ingester is already complaining about it, about something. This is like we really got notified about this issue that there's something wrong thanks to Linkerd, because it was harder to, like, Loki is processing logs, so basically it's working as expected. It's the Linkerd how we found that there's something wrong. If we click it over here, we can even learn a little bit more. We can check that there's incoming traffic from the following pods, and all the traffic that is coming from queryers is okay, but the traffic that we get from distributor part is the part that we generate some unsuccessful responses for. Okay, so we learned something. This is the only use case for us as it goes for Linkerd. And now the last part. So the third application that we have prepared, so Loki. It's a log aggregation and storage server that like uses this baseline that it's like Prometheus but for logs. But this is really essential also from the technical point of view, because it is basically the same ideas of labels and operations on labels that you can do, just applied not to metric values, but to log lines. So it is lighter and presumably should be also cheaper than Elasticsearch, even much cheaper, because it is using slightly different idea. It is not trying to index all the text that is coming from logs, but instead it is indexing only some labels attached to those text entries. And then it is trying to keep a relatively small index and do a distributed grab using this index. So basically, it just uses index to select batches of logs that need to be grabbed, and then it shuffles them across services to do a pretty efficient distributed grab. But you can grab for stuff that is not included in the index. That's why it is also smaller and more cost effective. Loki has embedded optional hard multi-tenancy. So you can run Loki in multi-tenant setup, and it is a hard isolation. I will show you a few more info about it in a minute. Already multiple log forwarders like Logstash, like Fluentd, Fluentbeat can forward logs for Loki, but Loki has a dedicated one that is called Promtail, and that's what we're using, and that's probably also what we should use and what we recommend for using. Loki has a dedicated queries that are a queries language that is called LogQL. I'm not going to talk about LogQL over here because this can easily take the whole session. Here's a link, have a look. It's really similar to PromQL, so the name is similar, not by a chance. There's one important concept you need to grasp before you start using that is different than in Promtail. So Loki uses static and dynamic labels. That's an important difference. Static labels are assigned to your log entry's fetch time, so where the log is fetched by a login agent, and this is basically what is put into index. So only static labels end up in index and can be used for partitioning the data set. Dynamic labels, which are perfectly fine to use, and it is the intended way for Loki to work, are created query time. So you query for your logs and you use some logic to explain to Loki what is a label for you in this log entry, and then Loki can do some additional operations based on them. One of the big advantages is obviously also great integration with Grafana, which is quite obvious because they are products of the same company. So our Loki cluster is deployed on Loki 0 cluster on Gorilla installation. This is currently a dedicated cluster, so nothing else runs there. We want to potentially limit the blast radius if anything goes south. Yeah, so it's a dedicated cluster. I was using Loki previously in many of my demos, but all of that was a demo quality Loki. So it was all in one, all services running in a single pod, non-scalable, non-HA, no persistent data storage configuration. This Loki that is deployed there is already a real Loki, so it is really deployed in the microservices architecture. It should be HA, it has persistent storage, and it has multi-tenancy enabled. And it's already available with a public HTTPS endpoint, can accept logs basically from anywhere if only authentication works. So, short demo of Loki. As you've seen, we have some problem in our Loki. Linkerd exposed that, and then some queries are not really working. We can try to investigate this quickly, but first let me show you how to configure Grafana to work with Loki. So there is a data source of type Loki. You need to give the endpoint for your Loki server. This is currently Loki operations Giantsworm.io. You need to use basic auth currently, and you need to give user and password. And what is important, you need to give your org ID by applying this header. So you need to set this header to indicate which tenant, which organization you are. Okay? More info about it coming again in the second section. Once you have done that, you can already go to the Explorer. And over here, we already have configured Promtail, the log forwarding agent, to run on the same cluster, the Loki 0 cluster, and forward all the logs from the cluster to Loki itself. So this is information about apps that are running on the same cluster as Loki does. And we've seen a problem with Loki application. So here are logs from Loki. And what we do get over here? Here, as you can guess, is frequency and the amount of logs. Over here, we have common labels. So all the log entries that we have queried have the same set of static, so in the index labels, and these are the 6. They were same across all the log entries. Labels that were different across the entries that we see are named over here in log labels. So these are the labels I can use if I want to improve my query over here and be more selective. Don't get fooled with those parsed fields and those like nicely colored bars over here. This is just some smartness Grafana does. So it's not really parsed. I mean, it's not parsed in Loki, it's parsed in Grafana. Grafana is trying to match logs to some typical formatting of values, and sometimes this works well, sometimes it doesn't. Anyway, this is just these are just hints from Grafana, nothing else. As you can see over here, I can, for example, say that I want to include component gateway as part of my query, and it works like that. But I can't do this for parsed fields because they are just some Grafana sugar fix for how the logs are displayed. Okay, so let's try to find logs that are not okay and that seem to be more interesting to me. Here we have some warnings, and they come from ingester. That's great. From Linkerd, I already know that the problem was in the ingester. Okay. So now I would like to get only warnings. I'm not interested in info messages. I can obviously browse that and try to check it out, but we can do a little bit smarter. Unfortunately, as you can see, in the static labels, there's no such label as log level. So I can't really filter by log level immediately. But what I can do, and that's what I wanted to show you as well, is to apply something that will allow us to use the dynamic label feature. And one of the ways you can use dynamic labels is to do a regexp with named capturing groups, and those capturing groups will be turned into dynamic labels. This is probably the hardest way you can do this, but also the most universal one. There are ready functions in Loki that can parse JSON, that can parse typical HTTP logs and such, so you don't have to write those long regexp parsing queries. But to get started with something, I will create a capture group called level, and this capture group should capture any word like sign, any word like character until space. Let's run this. Yeah, I got the regexp right, probably. Yeah. So as you can see over here, it already says level warn. This is a dynamic label that was created based on the text entry that is in each of the entries that is filtered based on the static labels. So now I can easily ask Loki to give me only, maybe not warn, but let's say not info. Not info. This should work. No. What have I missed? My logql failed. I thought that I can make it into a valid query. Yeah, it works now. What have I done differently? I don't know. Doesn't matter. So now we have only warnings, okay? And yes, this is a problem we have in Loki, and we haven't resolved it yet. We are not even sure what is it about exactly, but we can at least nail down all the issues over here. And that's just a start for LogQL because it is quite elastic. For example, like if you wonder what is the rate of those logs and does it increase or stay the same, we can, for example, count 10-minute rate of those logs, and it looks like this. So the great thing is that you can produce graphs out of logs, and you can even do this live. So I can enable live queries, and this will be processing. Well, it's a lot of logs to process, but this should enable my constant processing and updates of this value as the logs come into the Loki. Okay. So yeah, what's nice is that this is the explore mode, but obviously you can switch to dashboards, and when you're happy with your queries, you can create a dashboard, include a new panel, switch this panel to Loki, enter a query that we have over here, wait for results. Out of here, we have, these are really two graphs because we get one for each of the nodes. So as a legend, the best idea is probably to use a node name. And we already have this graph. And there are really quite a lot of transformations. So you can easily turn logs into graphs. And even more, you can then expose those values that you have as a graph. You can expose them as Prometheus metrics. So you can get Prometheus metrics live out of logs that are coming into Loki. And obviously, you can also make it simpler, like if your query doesn't really return any graph because you're searching for logs, this will work as well. I mean, you probably want to make your logs shorter, so do some transformations to only include the information you really care about. But you can as well present just raw logs, all the entries that were found by this query. Yep, that's a short demo of Loki, how it is, how it runs. In the second part, I will include more information about how our Loki installation exactly is deployed and how you can use it right now to forward logs from any cluster you want, and just a little bit about Loki internals. But so far, if you have any questions, feel free to ask. If there are none,
yeah, I have some.
Yeah, go ahead.
Yeah, first, thank you. Question is, so we include like in the package the Flux, Linkerd, Loki. So it's all deployed at once.
Yeah, this was the scope of our last cycle, but they are not in any package. So we just installed all of them, 3 of them separately on the same cluster, because it does make sense. I mean, we wanted to test exactly that scenario. Flux for managing the configuration and the way you configure and deploy apps, Linkerd to improve our observability, especially for an app we don't have much experience with, and Loki as the logging solution we are targeting.
Okay. So imagine that we go forward. I guess that you can run Linkerd as a standalone deployment, right? Because you want to use it in general.
Yes,
and then
it's running that way.
Yeah, and then you deploy, for example, Loki. How do you integrate the it's easy. I don't know for Linkerd. How do you integrate the configuration of Loki with Linkerd? Do you include the configuration files in Loki?
Yeah, the best thing about Linkerd is that you don't. You just deploy Linkerd, and then you annotate a namespace, a deployment, or a pod with basically Linkerd include this in service mesh, and that's it. Linkerd is watching all of those objects in the API server. If they have this annotation, they will be injected. But there are no config files, no other changes you have to do to include your deployment in Linkerd's mesh.
But is namespace the only way to include it, or there is also a tagging, a label in the deployment or in the pods?
It's annotation. You annotate the deployment or the namespace.
Okay.
Yeah, if you annotate the deployment, it's only the deployment. If you annotate the namespace, it's everything that's running in the namespace.
Okay, so this is something you have to add when you deploy Loki. For example, just annotation, extra annotation for that, or in the deployment, extra annotation for that. Okay.
Yeah, we just annotated the namespace to include everything that is in Loki namespace.
Okay. Okay.
Okay, I see some other. Yeah, go ahead.
No. I leave a space for others.
Sure. Yeah, when you press live in Grafana Loki, this should update all the incoming results based on the query. So this query is constantly executed on the backend and updated over here. I've even seen, like in the Loki workshop I was in, They were even showing off, for logs that are coexisting, correlated with IPDB database. They were showing live where are they getting hits on Nginx web server from where around the world, based on logs only, and they were doing this live. Pretty cool.
Yeah, cool. Thanks. I asked the question before you showed in the demo, so
yeah,
you
sorry,
basically answered
I'm
it.
reading the questions just
Yeah,
now.
all good. Yeah.
Can Flux have a template cluster and then create concrete ones from it? I don't think so. I mean, you can have template files, but I think I don't know.
I think it should be possible using customizations. So you can define your cluster CRs, all the resources you want, and then just add another customization which overrides all the values, names, etc.
Yeah.
You mean via overlay?
An overlay, yeah. Okay. But I think they deprecated the name.
Flux.
Okay.
Okay. Any other questions about the demo part?
It's not really demo, but it's more for managed apps. It's like Flux CD is intended to be run in the kind of our control planes, right? Because it's a multi-cluster deployment tool, like the new Flux 2. Instead of running it in every cluster. I mean, if we want to kind of leverage on the advantages Flux brings to us and not implement it in our own operators, then we can maybe tie together, right? And then use it. This is something that you have, in mind, or?
Yeah, currently our use case is for Flux to not be multi-cluster, but to target control plane cluster only. So it applies app CRs and config maps that are needed for app CRs for you. And from there, app operator takes over and applies the app wherever is needed.
Okay,
it is possible to use Flux for multi-cluster setups where Flux targets another cluster, a different one that it is running on. But we have a slight issue in using that. We are testing that, and there's a slight issue. Currently, it doesn't work directly. We rather don't want to replace it.
Okay.
I mean, the issue Lucas describes is that our operators create the kube config differently than Flux expected, but it should be possible to change that in our stuff, and so it could be definitely used as a replacement for some of our own operators, Flux.
Okay, but the idea is open this to the customers, like let them, plug repositories into this Flux. Like I want to deploy, I don't know, these apps or whatever.
That's a great question, and I think it's mostly for SEs actually. So ask the customers if they are interested in that. If they are, and I think that some of them might be, then yes, we can think about it. So far, it's only on Gorilla because it's testing installation. But I think we didn't have any issues with it, actually, right, Gerald?
No.
Yeah, I guess this question will just come up in the future from some customers, like GitOps ways. And so it's good if we start some testing internally first, so to be prepared. Yeah. So if a customer is interested and wants to work with us, like to join forces to find out what their need is, and so I think we are happy to get some, to do this with them.
Yeah, and if there's an interest, we can think about configuring Flux on all the control planes probably, and then customers are open to use it to target their own clusters. We have to figure out the security of it, obviously, because right now it is internal usage, so yeah, much easier. But that is basically the idea.
Yeah, at one point, Flux 2 was created, and now they are basically putting out new versions every few days. So there is still some movement there. but cool to follow, cool to learn. Just maybe there might be some friction in the next weeks or months, maybe still.
Okay. Let me move on because we can run out of time actually. Okay. So because like from what we got from you, the main interest out of these free apps and the most questions we got were around Loki. This is like a second part of my presentation today, which is more about Loki. So short information about how Loki works, what it needs, and how to use it, because we have already multi-tenant installation that is ready to be used. So first of all, Loki architecture, as brief as I can do it. There are two independent service paths in distributed Loki setup, like the one we have. There's a write path and a read path. This is great from architecture point of view, I think. So the write path starts over here with your jobs. Your jobs is basically what Promtail does. So Promtail scraps your logs, filters them, figures out what you want to do with them, and then ships them remotely to Loki. In Loki, they end up in the distributor service, which just takes care of how to distribute the incoming logs across multiple ingesters, which are responsible for making logs into blocks, and then figuring out which labels need to be included in the index, and then writing index and chunks of logs into persistent storage. Now, the query path, the read path, starts with Grafana, usually, because this is the best client you can get currently for Loki. The queries arrive to the querier service, and querier goes to persistent storage and ingester for on-the-flight logs, combines them together, and returns consistent query returns to the client. Okay. Additionally, in our setup, there are two more components. So in front all of that, there is a component called gateway, which is a part of Loki deployment, but is actually a pretty standard Nginx pod that is just driving necessary requests to necessary endpoints. So for example, if that's a request for storing logs, it drives that to distributor. If that's a request for reading logs, it drives that to querier. That's basically what it does. And there's one more service, but not really important in this scope right now. Please note one important thing. We had Loki already in the Playground catalog. This is not the Loki I'm talking about. That Loki is the all-in-one, no persistent storage demo only, and so on. There's a new Loki app in the Giant Swarm catalog with an alpha tag, and that's the Loki I'm talking about, the highly available multi-tenant, and so on. Loki is quite flexible in configuration. Like there are in total at least 5 services running inside, and the chart itself and the deployment itself is pretty complex. We made some choices about how we want to run Loki for us. First choice is the index database. There are many choices, like you can use, for example, some of the cloud providers' table storage, like DynamoDB on AWS to store your index. But the cheapest possible solution, and also one of the easiest to configure, is use the embedded BoldDB solution. This is a kind of database that they used internally that can be like partitioned, or in general, they are happy running this inside Loki. They keep index in this database, and the storage for this database can be the same as the actual storage for logs. And for logs, and thus for index as well, we are using S3. This is pretty cool because Loki doesn't need any full-blown huge database like, I don't know, Elasticsearch or Cassandra or anything like that. It is the database, like it can already do the search as necessary. It just needs a persistent log storage, and it's happy to work with something like S3. There's that additional component called gateway, which I already explained to you, and one more additional component in our deployment that is called compactor, that is not involved in either write or read paths. It is just about compacting the data that is already in S3 storage to increase efficiency and decrease cost. And now, running Loki, if one of our customers or you want to run a separate Loki installation, should be pretty straightforward, except of AWS setup. So there's one requirement, although pretty simple. Your pods need to be able to access S3 storage bucket that you configured for use with your Loki. Currently, we have this set up and tested on AWS only. Azure service is S3 API compatible, so should work as well, but that's not tested. And our docs currently describe all the details you need to do in the setup, but on AWS with KIAM only. So that's the only setup that we tested so far. Now, important thing, especially if your customers will be asking about it, and also if you want to store logs with our Loki instance that we have, is about auth. So basically, Loki doesn't do any authentication. There's no such thing as login into Loki. Loki supports strict multi-tenancy. By strict, they mean that all the logs are assigned to a tenant. There is no cross-tenant data access ever. So when you're doing queries or log storage for one tenant, there's nothing you can get out of other tenant. No cross joins, no cross queries, no nothing. And also, additionally, within a single tenant, there's no further data isolation, no authorization. If you're part of a tenant, you can access everything that this tenant has. Now, how Loki tells one tenant from the other? It is as simple as it can be. It expects every request, both for storing logs and for querying logs, to have Xscope org ID HTTP header, and that's it. The ID that is included in this header is the whole authorization information that Loki has. So this means that everyone that is using Loki, so both shipping and querying agents, need to set this header, which is definitely supported in Promptail and Grafana, which is the base use case for us. Now, there's no authentication, but we have authentication, a weak form of authentication, thanks to this additional gateway component, which is, like I said, actually an Nginx configured to work with Loki, which has just enabled HTTP authentication, the basic auth. So currently, to be able to submit any query towards our Loki, you need to have both. You need to have user pass for basic authentication, and you need to have your tenant ID to access the correct tenant that you're assigned to. But there is no verification of user password versus tenant ID. So once you're authenticated, you can pretend to be any tenant you want. This is a drawback of this setup. We know about it. We need to come up with a solution. Unfortunately, there's no solution by default. So you kind of have to figure out on your own how to do an HTTP front end that can do matching of this org ID header versus the user pass that was used for basic auth. Right now, this is only internal, so we're good, but you have to be careful to not use incorrect tenant ID, because you can push logs of one tenant for another tenant, for example, okay? Now, as I said, there are more apps, actually, because in the Loki package, there's Promptail. Promptail is the log forwarding agent, so something that can run on any cluster and forward logs to remotely running Loki. It works very much as Prometheus scrape configs. So it also is based on this idea of rewrite rules like Prometheus does, and it scrapes the logs and takes the labels, and then you can do everything you want on a label. So you can rewrite, add, remove, filter, and then you can create labels out of log entries, and so on and so forth. In general, it's pretty complex like Prometheus and pretty flexible like Prometheus. What is important is that Promptail sets tenant ID for upload requests, and you can run multiple Promptail instances in parallel on a single cluster, single node, and so on. This means that actually many multi-tenant setups are possible. So it is definitely possible to have one Loki and push logs from different clusters and have a different tenant for each cluster, and they will never mix logs between different clusters. But if you can configure your Promptail to do what you want, so for example, I want to have multi-tenant access where every tenant is a single namespace in a single cluster, that's totally doable. You just have to run one prompt tail per namespace and make this prompt tail to filter out logs of only this namespace and apply the correct tenant ID. So this should be pretty elastic, but that's it. It's, again, all based on this tenant ID, the single ID that needs to be attached to every request. So on this Loki 0 cluster, we have already created an HA scalable with S3 storage Loki that is running, that is getting logs about its own cluster. And it should be totally fine. And that's what we want to do, to push more logs to it. So Halo runs this Loki instance as if it was an app that we run for our external customers. We basically take care of it. Sorry. If you're wondering about costs, I think that our costs should really be reasonable because we don't need any of those more advanced databases. So far we have 3+2 nodes running there, 3 on demand and 2 spots, plus the S3 storage. And there is no other cost involved. Well, transfers, such things. Our setup is very similar as the one that they have on Grafana Cloud. It is actually based on the same architecture of setup, except that so far we have no memcached. To make it even faster for Grafana, they have huge instance. They run memcached additionally as an HTTP proxy cache in front of almost all the services. This is skipped in our case. Our endpoint for pushing and querying logs is already public, and you can use it right away. You can include logs from any other cluster, just ping us before you start. And you can check a sample configuration file that is needed for prompt tail over here. This is the file that we've used to set up prompt tail on the Loki cluster itself. We have deployed a dedicated Grafana instance to query our Loki. That's the Grafana I was using for the demo. You have to configure your Loki data source in Grafana to include this tenant ID. This is what I showed you with this Xscope org ID. That is, wait, I can still quickly switch, discard this dashboard. Yeah, it's included over here, right? The cool thing is that, well, we have basic auth enabled. That's not the cool thing. I told you already that there are some drawbacks of it, but you need to have a valid user and password. If you want one, again, ping us. Let's figure out how we want to set up and add a user and so on. All in-transit and stored data is encrypted. So because the ingress itself runs over HTTPS, and then we have Linkerd, which encrypts for us all the in-transit traffic, and then the storage is encrypted. This should be actually really safe for the logs that we are storing. There is an asterisk there because we still have some issue with securing one section of the transport pipeline within the service mesh. We are not really sure why. We have to investigate. Our default data retention so far should be 3 months. So that's what we set up. All the logs that you push right now should be stored for 3 months. Our default prompt tail config file that you can find over here should forward for you by definition, by this config, not by definition, all the Kubernetes pods that are running on the cluster you are deploying this to, and all logs from systemd journald, which is pretty cool because you get logs from, all the system services, including kubelets. But again, there's a glitch. Something is not working, like timestamp ordering is not working. We are not sure yet why. So this is not really yet working, but should be soon. Again, if you want to add a new cluster, just ping us and we will tell you how to do this and work on this together. We also will provide and prepare docs about how to add your new cluster, because once you get a user, a pass, and an org ID, it's as easy as deploying the prompt tail app. That's basically it about how Loki works. We have a lot of open questions. I just wanted to point out to some of the most important one. They will be probably most important for Atlas, I guess. So right now, Loki is running on a dedicated cluster. because all the data, all the logs and index are actually stored in S3, it should be really easy to collocate later. So if you want to aggregate clusters later to save some cost on running masters, we should totally be able to do that. Now, the important question, even probably before we start pushing more logs into Loki, is how to organize our clusters into tenants. Like I said, currently there's only one tenant, which is Loki 0 cluster itself, but for what's logs about itself. But we have to think about how to organize all the rest that we want logs from into tenants. So should all our clusters use just one tenant, maybe, or maybe just management control planes? Because it is definitely useful to be able to query, I don't know, app operators across all the management planes at the same time. That's definitely something we want, I think. So probably we won't create a separate tenant per each control plane, right? Just something we should discuss, think about, and so on, Grafana. Actually, this Grafana that we run is pretty much pointless because we run a bunch of Grafanas. Every installation has a Grafana already. So the question is, should we reuse it? I think that the answer is yes, because over here I was using Grafana only for logs. If we use a Grafana where we already have access to metrics, then it gets even better, because you can get metrics and logs at the same time, and you can even push them into the same dashboard, and you can mix and match and correlate them all the way you want. But in general, it's still an open question. So far, we have a dedicated Grafana just for querying logs. That's it. Thank you, everyone. If you have any questions, I'm happy to answer.
Fine, like same approach we are doing with Prometheus, like set Loki for short term, and then send it to something like Grafana Cloud for long term. Not that kind of aggregated. It makes sense. It's useful for us. Or...
First of all, I'm not sure if you can do that. I haven't seen such an option. You can chain prom tails together. So you can chain prom tail to prom tail, but I haven't seen a solution to chain Loki to Loki, actually. But also, I'm not sure if it does make sense to push our logs for long-term storage to Grafana Cloud when actually, like, long-term storage is probably less important for us and less critical, and we can get much cheaper than we already are, because our Loki installation that you see over here already has like very low requirements, already is storing everything on S3, and even this S3 has a private VPC endpoint to keep transfer costs down. So this should be really competitive in pricing. So any other questions?
Yeah, I just wanted to go back to Flux quickly. I think it looks really cool the way we're using it to manage like the CRs and the resources, like related resources. I'd just like to see, whether we could use it with the emission controller as well, because I've been trying to like simplify the app CRs. Don't know quite how that would work with Flux, whether we can submit the simpler one and still have like the full stuff, because then you wouldn't have to set like the kube config, all that kind of stuff. But overall, I think it looks nice as a way of managing the CRs.
Yeah, I think that for Flux, it doesn't really matter. I mean, Flux just takes YAML from a repository, converts that to an object, and applies to Kubernetes API. So even if we have app admission controller and we have the shorter app CRs in GitHub repository, I think this should work fine. Not tested, but I don't expect any issues.
Yeah, cool, sweet.
Okay. We're good then? Thank you, guys.